Hi everybody, welcome to East Tutorials. We are going to see a series of sorting algorithms, and in this video we are going to see an introduction for sorting. So first we look at an analogy as usual. You are having two shelves. So the first case your dresses are in a messy way. In second case you are having everything in an organized way. Suppose you want to choose a blue color dress and you want to wear it. So which will be easy for you, whether this messy shelf or an organized shelf? We always prefer organized shelf because searching will be very easy in this. Same way, the technique of keeping things in an arranged order is called as sorting. So if you are keeping everything in an arranged order, that is sorted order, it will be easy for you to search something. So what is sorting? The operation of arranging a set of data in some given order is called as sorting. So what is that some given order? So generally there are two types of order which we follow. The first one is numerical order and the second one is lexicographical order. Numerical order means the data which you are supposed to sort will be of numbers and you have to sort it in either ascending order or descending order. That is numerical order. The second one is lexicographical order, which we see in dictionary. So in dictionary, alphabetically according to ABCD order, the words will be arranged. That is called as lexicographical order. So the operation of arranging the set of data in either numerical order or lexicographical order is called as sorting. So examples, we can see many examples for sorting. We always arrange things around us, data around us in order. So best example is telephone directory. So all the names will be arranged in alphabetical order. Similarly in the dictionary also. Imagine if in the dictionary the words are not arranged in the correct order, if you want to find one word's meaning, how will you do that? You cannot keep on going through page by page for searching that word. So arranging things in order, arranging data in particular order is very important. Rank list or your mark sheet or student details. So based on register number, all the names will be sorted and the corresponding data will be available. Suppose for register number 15 I want to search, I need not go line by line. Directly after 10 if I start searching or after 12 if I start searching easily, I can pick that register numbers, person's name, detail, mark list, etc. So sorting is very important. So you have to be very clear between sorting and searching. They are entirely different. So you are arranging the number of either alphabets or numbers in the order, that is called as sorting. So you are performing arranging operation. Searching means you are performing finding operation. You are given with the search element. So generally technical name for search element is key element. Suppose I want to search 15th student, like that we saw now. So if I want to search that student in the list, 15 is my search element. So that is technically called as key. So with that key, where is that key present? Like that I have to find the position and I have to take all the corresponding data with that. So that is called as finding. So sorting will be returning the entire array in the arranged order. Searching means for the given key element, the position of that will be searched and returned. So that is searching. Example for sorting algorithms are internal insertion sorting, bubble sort, selection sort, merge sort, quick sort, radix sort, etc. And for searching, generally linear search and binary search are used. We'll see all these in the further lecture series. So first, sorting we saw. It is arranging the data. Here I said the example. In case of searching, what key element you are giving to search, that will be displayed. That corresponding record will be searched and displayed. For example, I want to see 25th register number means the roll number 25 will be searched and that details will be written. What is the need for sorting? So it makes the searching process very easy. That is why we go for sorting itself. If you are searching in an unsorted data list, it will take big O of n. Whereas if you are searching in a sorted data list, it will take only big O of 1. Applications of sorting, it cannot be restricted with these few applications. There are many vast applications. Few are sorting list of names, mp3 library will be arranging, then displaying the page rank result in Google, then commercial computing, operational research, simulations, that is especially event driven simulations, then combinatorial search. Best example in student level is roll numbers in merit list. We always search. So these are some applications of sorting. Problems that become easy after sorting is finding median. So median means you will be given list of numbers. First you have to arrange them in ascending order and you have to choose the middle element. That is called as median. For example, you are having certain numbers 8, 5, 3, 1. So first, if you want to find the mid element, means you have to median means you have to arrange this in the ascending order. So 1, 3, 5, 6, 8. So among this 5 is the median. So for if you want to find median, first you have to sort and then only you have to find the median. So finding median is one best example which uses sorting. Without performing sorting, you cannot find median at all. Same way, closest pair. So if you are taking the number which is the next closest number or previous closest number, you have to pair them. For those problems also, sorting is a mandatory one. Then searching in the database. So if you are keeping your database in a sorted order, then searching becomes easy. And finding the duplicates in the list. So if it is in the sorted order only, you can find whether it is the duplicates are present or not. So in a big list, if you are giving one number and you are checking whether duplicate is present, it is easy. So in the entire list, if you want to remove duplicate, sorting has to be done. So few sorting algorithms which we will be seeing in the forthcoming lecture series are selection sort, bubble sort, insertion sort, cell sort, radix sort, quick sort and merge sort. So all these sorting algorithms we will be seeing with animated example. We will be seeing animation for a story like analogy we will be having, and we will be learning sorting algorithm. Then step by step execution, how the compiler will execute step by step. That also using animation we will be seeing. A clear explanation of all these sorting algorithms will be provided in the forthcoming lecture series. Then you have to know about the efficiency of sorting. So sorting techniques mainly depends upon two parameters, execution time and the space. So execution time means the time taken for the execution of the entire program for the given input. That is called as execution time. So if your input is n, it will be the execution time will be represented in terms of n. Space means the space taken by the program for execution. If any extra space is taken or not, that can be known with the help of space complexity. So the execution time and space are the two measures which we use for finding the efficiency of the sorting algorithm. There are two types of sorting, internal sorting and external sorting, which we will be seeing in the next lecture series. And in the forthcoming lecture series, we will be solving all the sorting algorithms one by one. Stay tuned to these tutorials. Like, share and subscribe.